Hi, if you couldn't tell by the title already, this is about chapter 6.3 and it's all about collisions. So there are two types of collisions, elastic and inelastic. Inelastic collisions is when momentum is conserved, but the kinetic energy is not, so it's like when a car crashes, the kinetic energy is lost in sound and crunching metal. Elastic collisions are when both momentum and kinetic energy are conserved. So an example of this would be like pool balls, which you'll see in an example later on in the video. Now, if you have an inelastic collision, there are such things as a perfectly inelastic collision, in which the aspects are the same, but the two objects that collide stick together after, so the final velocity is the same. This can be represented by the equation of mass for the first object and velocity of the first object, plus the mass and velocity of the second object equals the mass combined and the same velocity. Here are just some equations that have to do with elastic collisions. Pause and copy them down. And since we want you to succeed, here are some strategies to approaching collision problems.
Now let's try a quick conceptual example that will help us understand the types of problems we can solve with what we know about inelastic collisions. Here we have two balls, each of a different mass, going at different speeds towards each other. Always remember to keep in mind that momentum is conserved and therefore the product of mass and velocity for both balls added together before the collision will equal their final mass multiplied by the final velocity after the collision. We can always manipulate this equation in order to find what the question wants. As we can see, post-collision, the two balls act as one, combining their weight and going at a common velocity.
So here we have an example of an elastic collision. We have two pool balls, and we are going to represent the one being hit as mass 1 with a initial velocity 1, and the second object, which is going to be mass 2 with the second initial velocity. So once the balls come into contact and the collision happens, what is happening is that the energy from the first ball is transferring to the second ball, which adds the two masses and velocities together to transfer the kinetic energy and the momentum. So when the balls separate, the second ball continues to roll and the first ball comes to a stop, with the second ball having the final velocity and momentum of the first ball, which makes an elastic collision.